Hello everyone. We are into the lecture 3 of week 8 where we had been discussing about various metrics associated with pricing strategy. In the last class we discussed about reservation price and how demand is related to reservation price, how we can decide on an optimum price point in order to maximize our profit. In today's topic we will be looking into price elasticity of demand. As all of us know that there is a relationship between quantity demanded and price set. For normal products, as you tend to increase the price of a product, depending on the sensitivity of the product, depending on the context, the quantity demanded for the product reduces. And this is well covered under the one law in economics, that is called law of demand. So, we know that there is something called elasticity of price. I mean, what is the percentage change of quantity demanded due to change in price of that particular product. So, that is covered under price elasticity of demand. In the last class, we discussed about something reservation price. So, in that also we have seen that as you try to put up the various price point that is reserved by various customers, we will be just picking up one price point where you get the maximum profit margin. So, as far as our last example is concerned, we set the price at $100 if you remember it correctly, right. So, it was neither $30, it was nor $130 which was the maximum reservation price, but maximum profit was coming when the price was set at $100. So, price elasticity also defines that kind of a phenomenon. Let us try to find out what is price elasticity. Price elasticity denotes the responsiveness of demand to a small change in price expressed as a ratio of percentages. This keyword is important. When we try to define price elasticity, it is not the absolute difference of change in quantity demanded, rather it is the percentage change in quantity demanded. From that perspective, it is slightly different from slope of a straight line. So, in case of slope of a straight line that we have seen in the previous class, it is not the percentage change that we had been talking about. Rather, we had been talking regarding the absolute change in quantity due to absolute change in price. Price elasticity measures the responsiveness of quantity demanded to a small change in price. Price elasticity can be a valuable tool enabling the marketers to set an optimal price. You need to understand what is the right price for your setup, for your industry. So, understanding the elasticity of price gives you a lot of insight regarding what should be the price set in order to maximize the profit that is coming from the product. If price elasticity is estimated at minus 1.5, for example, then we expect the percentage change in quantity to be approximately 1.5 times in percentage change in price. The fact that this number is negative indicates that when the price rises, the quantity demanded is expected to decline and vice versa. Remember that some of the books, especially in the domain of economics, rather than taking the absolute ratio, they used to take the mod of the ratio, and price elasticity may be visualized as a positive number. That is just a convention. But if I look conceptually, if I look at the law of demand, what does it say? That as you increase the price of the product, the quantity demanded for the product decreases, right. So, by definition itself, and what is price elasticity? It is percentage change in quantity demanded divided by percentage change in price change. So, basically by definition itself, it has to be a negative number. For convention, we can take a mode and keep consistency in portraying the number as a positive number, that is okay. But conceptually, price elasticity is a negative number for normal goods. Now let's try to find out the purpose of price elasticity metric. Primary purpose is to understand the market responsiveness to changes in the price. It gives you an idea about how sensitive the price attribute of the product is. It will answer the questions like if a small change in price will result in a higher change in quantity demanded, or is there a possibility that, let's say, if you increase the price by a bit, then will the quantity demanded collapse. So that is the sensitivity. If a little increase in price of the product collapses the quantity demanded, then in that case price elasticity is very high. Price sensitivity is very high for that product or for that particular segment. Price elasticity is the most commonly employed measure of market responsiveness to changes in price. Many marketers, however, use this term without a clear understanding of what it entails. A strong command of price elasticity can help the managers set the optimal price. Setting the right price in the right dynamics in the right segment. Remember that for the same product, the sensitivity of price will be different in different segment. Let me consider the grocery items as one single product. So what happens? If the price of the grocery items increase by, let's say, 50%. So then also, let's say, people who are in the high earning bracket, for them they will not reduce consumption of grocery items, because that particular, the overall percentage of expenditure that is occurred by the grocery items for people who are rich is very minor, is very low. So that is why for them what is going to happen, they are not going to reduce the consumption of grocery item. But think about another segment who are basically low earners and who are somehow surviving with their daily needs. So the percentage that is spent on the grocery items for that particular segment is very significant. In that case, if the price of the grocery items is increased by 50%, so what they will try to look? They will definitely try to look for alternative items. Same product but different segment, and price sensitivity of the product will be different. So that is why understanding price elasticity at a more granular level is very important. You should know which segment you are addressing, and you should know what is the price sensitivity in that particular segment, and then only you will be able to take a decision whether I should be able to increase the price of the product in this particular segment or not. So this becomes a data driven decision, and that's where price elasticity plays a role regarding setting the optimal price of the product in that particular segment. Let us now look into the construction of price elasticity metric. If we raise the price of a product, do we expect the demand to hold steady or crash through the floor? If the price of salt is increased by even 100%, I am not going to change the brand, or many of us probably will not go to change the brand, right? But let's say if the price of cars are increased by 50, even 20%, I am the first one to change the brand if I am planning to purchase a new car, right? So I mean, these questions will be answered by the context. So what does context include? It includes the segment that I am into, the type of product that I am dealing with, and ultimately what is my disposable income. So all these factors will play a role in answering this kind of questions. In markets that are unresponsive to price changes, we say that demand is inelastic. The example that I have cited. Probably people who are earning more, or even middle income people also, the price of salt is more or less inelastic. You increase 10%, 20%, 30%. So, how much salt you will consume in a month? Probably let us say you are spending 50 rupees in a month, even if that becomes 100 rupees, it does not matter much to your or my income. So, in that case it becomes inelastic for our segment, right. If minor price changes have a major impact on the demand, then we say that demand is elastic. 10% change in price of luxury car, and that is why, as it is a luxury item, probably I am not ready to pay even 10% more. So, by definition, by formula, price elasticity equal to change in quantity in terms of percentage divided by change in price in terms of percentage. This percentage symbol is important, otherwise it will just become your slope of a straight line. Most of us have no trouble understanding elasticity as a qualitative level. The challenge comes when we try to quantify this important concept, and that is where the construction of price elasticity metric, systematic construction of price elasticity metric is very important. So, when we try to visualize price elasticity as a metric or as a concept, then we face multiple challenges, and the first challenge that we encounter, most of us encounter, is what is the sign? Is it a negative value? Is it a positive value? What it is? Many economics books says that price elasticity is 1.5, 2, 3, 4 and so on, right. What is the sign? So, conventions may be different, but if I look conceptually, then the sign of the price elasticity is negative, because as per law of demand, what we say that an increase in price will result in decrease in quantity. So, percentage change in quantity demanded divided by percentage change in price change is ought to be a negative number, and that is why price elasticity for normal goods is expected to be a negative number. So, what do we indulge into when we try to analyze? So, most of us try to end this concept in the midway. Many people, however, simply assume that quantity goes down as the price goes up and jump immediately to the question of by how much. For such professionals, such people, price elasticity answers the question, and apparently it looks like a positive number. In their eyes, if the elasticity is 2, then the small percentage increase in price will yield twice the percentage of decrease in quantity. But in reality, conceptually, by definition, by formula, we could say that price elasticity is actually -2. So, first thing that you need to concentrate is on sign. Then we can talk about the challenge number 2. When the demand is linear, elasticity changes with price. Is it right or wrong? Does elasticity changes or does the slope of the line change? So, this is a bigger question. Most of us have no trouble understanding elasticity at a qualitative level, that we have already mentioned. The challenge comes when we try to quantify it. One challenge that is regarding the sign of the elasticity value, that we have already discussed, that normally it should be a negative value conceptually. The second challenge is what happens to elasticity. Is it a variable or is it a constant, especially for a linear demand. For a linear demand function, the slope is constant, but elasticity is not. Do not get confused with this concept. So, what is this? When we say it is a linear demand function, we mean that it is a straight line. So, we can represent this straight line with an equation y equal to mx plus c, where c is the intercept and m is the slope. So, if you consider that quantity demanded is a linear function, then in that case the slope will remain constant, but elasticity at various points will keep changing, and that we will see with example. I will demonstrate it with an example. Elasticity is not the same as slope. Slope is the change in quantity for a small change in price. Elasticity, by contrast, is the percentage change in quantity for a small percentage change in price. The difference is clear. In case of slope, it is absolute changes. In case of elasticity, it is the percentage changes. So, elasticity we calculate as a kind of compounding concept. Look at this example, and I think how the slope remains constant but elasticity changes, that will be clear with this example. Let us consider 3 points on a linear demand curve, that is when the price is $8, the unit sold is 100 units, when the price is $9, the unit sold is 80 units, and when the price is $10, the unit sold is 60 units. And you can also see it from the graph that is drawn on the left hand side. So, what does it say? Apparently, if these are the 3 points, $8, 100 units, $9, 80 units, and $10, 60 units. Apparently, without looking into any mathematics, I can say that every $1 increase in price decreases the quantity by 20 units. This is what it is. So, each dollar in price yields a 20 unit change in the quantity demanded. So, that is what explains is explained by the slope of the line, right. That is why the slope of the line is constant, that is minus 20, right. As the price rises from, now let us look it from elasticity point of view. Let us calculate it in terms of percentage. So, what we will be able to see that at some instances the percentage change will remain constant, at some other instances the percentage change will not be the same. Let's dive more into it with the numbers. As the price rises from $8 to $9, so what is the percentage change in price? It is 1 by 8, which is 12.5%. Now look at this one. What is the quantity declines from 100 to 80? So there is a 20% decrease in price. So what would be my price elasticity? 20 divided by 12.5, and that gives me a value of minus 1.6. Similarly, as the price rises from, let us say, $8 to $10, the first point and the third point I am talking about comparing, then the quantity, I mean that the change in price is 20%, price is increased by 25%. And what is the decline in quantity? It is from 100 to 60, that is 40%. So, quantity demanded by price change 40 divided by 25, that is again giving you a value of minus 1.6. So, for these two instances the elasticity remains constant. So, it appears that the ratio of the percentage change in quantity to the percentage change in price is minus 1.6 regardless of the size of the change that is made in the $8 price. Now, take another situation. What happens when the price rises from $9 to $10? What is the percentage change in price in this case? It is 1 divided by 9, that is 11.11%. Now look at the quantity, this one declines. So at $9 the quantity demanded was 80, at $10 the quantity demanded is 60. So 80 to 60, there is 25% decrease in quantity demanded, and that is why what would be my elasticity value? It is 25% divided by 11.11%. So the value of price elasticity in this context, when we look at a transition from $9 to $10, it is minus 2.25, which is totally different from the price elasticity that we have calculated earlier, which was minus 1.6. A price decline from 9 to 8 also yields an elasticity of minus 2.25. It appears that this ratio is minus 2.25 at a price of 9 regardless of the direction of any change in price, right. So what we have seen overall is that at different price point the elasticity is different, but the slope will remain constant throughout the all price points, and that is minus 20 in this case. Now let us try to understand the relationship between elasticity and slope, right. So what we will try to do in this case, we will try to establish a relationship between price to quantity ratio and price elasticity with the slope. So, let us revisit the same example. Let us look at the same demand function, which is linear function. We can see that the slope of the curve reflects a 20 unit decline in demand for each dollar increase in the price. That is, the slope is equal to minus 20. The slope formula for elasticity can be used to verify our earlier calculations. What we have to do in order to verify that? We have to calculate the price to quantity at each point on the line and multiply this by the slope to yield the price elasticity at that particular point. So, for example, at price $8, the quantity sold was 100 units. And what will be our price to quantity ratio? Price is $8, unit sold is 100, so it is 0.08. Now, you can simply multiply the slope at that particular price point with this particular ratio, that is price to quantity ratio, and that will give you a value of minus 1.6. 0.08 multiplied by minus 20 gives you a value of minus 1.6, which was the price elasticity at price point 8 that we have calculated earlier in our previous slide. We can also check the price elasticity at price point 9. So, what was the quantity demanded? It was 80. What is the price to quantity ratio? The price is $9 divided by quantity demanded is 80. So, 9 by 80 multiplied by the slope, that is minus 20. 9 by 80 multiplied by minus 20 gives you a value of minus 2.25, which is the elasticity at price point $9. Similarly, we can calculate the elasticity from this price to quantity ratio at price point $10. So, at price point $10, the quantity demanded was 60 units. The price to quantity ratio will be $10 divided by 60, and when it is multiplied by slope, that is minus 20. So, $10 divided by 60 multiplied by minus 20 gives you a value of minus 3.33. So, now by this time I think our concept is clear that for a linear demand line, for a linear demand function, when we are considering that demand function is a straight line, in that case the slope of the line will remain constant, but elasticity at various price point will keep changing. Fine. Now, let us look into another situation where the elasticity will remain constant. This particular situation is more practical as compared to a linear demand function. Though we have visualized the demand as a linear function, in reality it does not happen. Every price change, every unit price change does not actually change the quantity demanded by equal quantum. That is not happening in real life. So, what is a more practical conceptualization or visualization is that rather than a linear demand function, we are considering a demand curve with constantly changing slope. So, a second common form of function used to estimate the demand entails the constant elasticity. Now, in this case, we are keeping the elasticity, that is the percentage change in quantity demanded divided by percentage change in price will remain constant, but slope will keep changing. This form is responsible for the term demand curve. It is not a straight line, it is in reality it is a curve, right. In contrast with the linear demand function, the condition in this scenario are reversed, that is elasticity will remain constant while the slope changes at every price point. The assumption underlying a constant elasticity demand curve is that a small percentage change in price will cause the same percentage change in quantity demanded. Now, we are talking about percentage change rather than absolute change, regardless of the value of the initial price point. That is, the ratio of change in quantity versus price expressed as a ratio of percentages is equal to a constant value throughout the entire curve, throughout the entire function, and that particular constant value is known as price elasticity. So, you can just simply have a look at this graph, right. So, where the price is $8, then quantity demanded was 101.7, price is $9, quantity demanded was 78, then price is $10, quantity demanded was 61.5. So, if you look at this percentage change in quantity demanded from $8 to $9, then we will be able to see that if I calculate it in terms of percentages, then in that case this ratio of percentage change in quantity demanded by percentage change in prices will remain constant for price point $8, price point $9 and price point $10. But slope at each of this point will keep changing. In mathematical terms, in a constant elasticity demand function, slope multiplied by price divided by quantity is equal to a constant value, which we are terming as elasticity for all the points along the curve, whether it is at price point $7, $8, $9 or $10, this ratio will remain constant. Now, for this constant elasticity function, we can also derive an equation for quantity demanded. Remember that this is not a linear function. So, the equation y equal to mx plus c is not going to work here. So, in that case, in case of a linear line, we used to have something called a intercept and we used to have something called a slope. So, now as it is non-linear, we will instead of intercept, we will have something called a scaling factor. Scaling factor is nothing but the base of the equation, and we will have something called elasticity instead of the slope. So, the quantity demanded can be devised, can be visualized with this formula QP equal to A multiplied by price point to the power elasticity, where A is the scaling factor and elasticity is the price elasticity at that particular price point. It can be viewed as the quantity that would be sold at a price point $1, assuming that $1 is the reasonable price for the product under consideration. In case $1 is not a reasonable price for that product, then in that case we have to either scale down or scale up the data points. Basically what we are doing is we are converting the standard deviation of the data point into unit, that is 1. So, that is what we need to do in order to conceptualize the price elasticity with a non-linear function, that is QP equal to A multiplied by P to the power elasticity. So, in its way constant elasticity is analogous to the continuous compounding of interest. So, what does continuous compounding of interest refer to? Basically, let us say I invested 100 rupees and rate of interest is 10%. So, in the next year I will get a total gain of 10 rupees, but if I keep that value, so next to next year the value will not be 10 rupees because it will be compounded. The base of my calculation for the second year will be 110 rupees rather than 100 rupees. So, my total value that is accumulated at the end of the second year will be 121 instead of 120, and this is what is a non-linear function. In a constant elasticity function, every small percentage increase in price generates the same percentage decrease in quantity. This percentage decreases compound at a constant rate, leading to an overall percentage decrease that does not precisely equal the continuous rate. And for that reason, as it is not a constant value, first year I am getting 10 rupees value, second year I am getting 11 rupees, third year I will gain some more than 11 rupees. So, as it is not a constant, for this reason, given any 2 points on the constant elasticity demand curve, we can no longer calculate the elasticity using finite differences as we could when the demand was considered reliable, I mean linear. Instead, we must use a more complicated formula which is grounded on the natural logarithm. So, elasticity will be natural logarithm of quantity 2 divided by quantity 1 divided by natural logarithm of price point 2 divided by price point 1, fine. So, if this is the formula, then I can easily calculate the elasticity value for this given demand curve. So, for this demand curve, let us say at $8 the quantity is 101.669 and let me call it the price point P1 and quantity point Q1. At $9 the quantity is 78 and let me put it as price point P2 and Q2. So, inserting these values into our formula. So, what is my quantity demanded? Q2 is 78, Q1 is 101.669 and P2 is $9 and P1 is $8. So, if I take the natural logarithm of both the denominators and the numerators, then I get a value of minus 2.25, which was the value of the price elasticity. If we had set P2 equal to $8 and P1 equal to $9, we would have arrived at the same figure for elasticity. In fact, regardless of which 2 points we select on this constant elasticity curve, regardless of the order in which we consider them, elasticity is going to be minus 2.25 throughout the curve. So, we can see that elasticity is remaining constant, but on the other hand, if we try to calculate the slope at various points, we can see a difference. You can do it of your own from these values. Just you do del q by del p, then in that case at various price point the value of slope will be different. So, this is what was for today. Basically, what we discussed about the concept of price elasticity. What we looked into is that how quantity demanded can be visualized in terms of a linear demand function where the slope of the line will remain constant, but elasticity will keep changing, and we have also seen that how quantity demanded can be visualized in terms of a demand curve where the elasticity at various price point will remain constant, but slope at those price points will keep changing, right. Thank you. I will see you in the next class.